Chromatography is used to separate and identify the components present in a mixture containing non-volatile components. There are many different types of chromatography techniques. The method carried out using paper is known as paper chromatography. It is considered to be the simplest and most widely used techniques because of its applicability to isolation, identification, and quantitative determination of organic and inorganic compounds. Paper chromatography was first introduced by German scientist Christian Friedrich Schonbein in 1865. Paper chromatography is an analytical method used to separate colored chemicals or substances. The principle of separation is mainly partition rather than adsorption. Substances are distributed between a stationary phase and mobile phase. Cellulose layers in filter paper contain moisture, which act as stationary phase, and organic solvents are used as mobile phase. The developing solution travels up the stationary phase, carrying the sample with it. Components of the sample will separate readily according to how strongly they adsorb onto the stationary phase versus how readily they dissolve in the mobile phase. Paper chromatography mobile phase. Pure solvents, buffer solutions, or mixture of solvents can be used. The commonly employed solvents are polar solvents, but the choice depends on the nature of the substance to be separated. If pure solvents do not give satisfactory separation, a mixture of solvents of suitable polarity may be applied. Steps in paper chromatography. Number 1. Selection of stationary phase. Fine quality cellulose paper with defined porosity, high resolution, negligible diffusion of sample, and favoring good rate of movement of solvent. Number 2. Selection of mobile phase. Different combinations of organic and inorganic solvents may be used depending on the analyte. Number 3. Saturation of tank. The inner wall of the tank is wrapped with the filter paper before solvent is placed in the tank to achieve better resolution. Number 4. Sample preparation and loading. If solid sample is used, it is dissolved in a suitable solvent. Sample, which is around 20 microliter, is added on the baseline as a spot using a micropipette and air dried to prevent the diffusion. Number 5. Development of the chromatogram. Sample loaded filter paper is dipped carefully into the solvent not more than a height of 1 centimeter and waited until the solvent front reaches near the edge of the paper. Number 6. Drying of chromatogram. After the development, the solvent front is marked and left to dry in a dry cabinet or oven. Number 7. Detection. Colorless analytes detected by staining with reagents such as iodine vapor, ninhydrin, etc. Radio label and fluorescently label analytes detected by measuring radioactivity and fluorescence respectively. Applications of paper chromatography. To check the control of purity of pharmaceuticals. For detection of adulterants. Detect the contaminants in food and drinks. In the study of ripening and fermentation. For the detection of drugs and dopes in animals and humans. In analysis of cosmetics. Advantages of paper chromatography. Simple, rapid. Paper chromatography requires very less quantitative material. Paper chromatography is cheaper compared to other chromatography methods. Both unknown inorganic and organic compounds can be identified by this method. Paper chromatography does not occupy much space compared to other analytical methods. Excellent resolving power. Limitations of paper chromatography. Large quantity of sample cannot be applied by using this technique. In quantitative analysis, paper chromatography is not effective. Complex mixture cannot be separated. Less accurate compared to high-performance liquid chromatography. Thank you everyone.